Hello everybody. In this video we're going to be going through Reconstruct Original from English, which is LeetCode problem 423. So this is marked as a medium problem and as far as frequency it was pretty popular. When I usually sort by frequency and it was at the top. Given a string S containing an out-of-order English representation of digits 0 through 9, return its digits in ascending order. Okay, so example 1 has S equals and then this gibberish. But the output is 0, 1, 2. So you can see there's a, if you unpack this, it's Z, E, R, O. There's a 0 in there, there's a 1 and a 2. In example 2, this one's a little easier to see. You have 5, F-I-V-E, and F-O-U-R, so it outputs 45. All right, so how are we going to do this? Well, hey, let's figure it out. Okay, there's some things we need to touch base on first. There are 5, of the 10 letters, there are 5 that have unique letters in them, and they are as follows. The letter Z only appears in 0. The letter W only appears in 2. The letter U only appears in 4. The letter X only appears in 6. And the letter G only appears in 8. I think it's funny, these are all even numbers. 0, 2, 4, 6, 8. Anyway, the other letters, or the other letters do not, or the other numbers don't have unique letters. So for example, the letter O appears in 1, but it's also in 0, 2, and 4. The letter H appears in 3, but it's also in 8. The letter F appears in 5, but it's also in 4. And the letter S appears in 7, but it's also in 6. And the letter I appears in 9, it's also in 5, 6, and 8. So how this is going to work is we're going to look for these unique letters. So for example, I just put this in order, but 0, 2, 6. So we've got one Z, so we know there's the word 0 in there. And then we've got one W, which can only be the number 2. And then we've got one X, so that can only be the number 6. Now for the case of 0, 4, 5, we've got one Z for 0. We've got one U for 4. But for 5, we've got, basically you have to take the number of, we have to subtract out the 4. So we have one U, so that we automatically know that there's a 4, so there's an F associated with that U. And so we just subtract that count of 4s. And so if we still have an F left over, then that will be the 5. So let's dissect that a little bit more. So what we're going to do, or what I propose, is we create a new int of 123, and I'll explain that in a second. So we're going to loop through each string in the input, each character, and then we're going to get a count of each character. Now you notice that this is an integer, not a string. So when you're doing a character, it's actually doing the decimal value. So when let's say there's a letter A, it's actually putting a 97 in the count. Now another way to do this, I guess is a little bit cleaner maybe, is to just do a new int of 26, which is, for the 26 letters in the alphabet, and do the same thing, go through each character, and then you can do C minus the character A. Now so let's say you have A in this case, so you're going to get 97 minus, and then it's going to be 97, so it'll be 0, which is, into 26, 0 is the first index as the letter A. And that's, I guess that's it's a little bit cleaner, but it's extra. These are just numbers behind the scenes. We're not actually displaying these numbers, so it doesn't really matter to me what the numbers are. I'm just going to do it the first way because it's less confusing, I think. But to each their own. All right, so we're going to define an int number, a new int 10. So this is going to hold 0 through 9. So we're going to get the count of z's in the count. Actually, this is the sorry. This is the count array. So we're going to get the count of z's in count, and then we're going to get the amount of w's in the count array, number of u's, the number of x's, and the number of g's, and that will signify 0, 2, 4, 6, and 8. So now, to get the number 1, we're going to get all the count of the o's, but we're going to have to subtract out the number of zeros, the number of 2's, and the number of 4's. And if there's any letter o's left, then those are going to be 1's. Same thing with h's. Subtract out the number of 8's because there's an h in 8, and if we have any left over, that'll be the number 3. 5 is the same thing with the f. 7, we do the same thing with the s. And then 9, we are going to take the I. Subtract the number of 5's, the number of 6 and 7's. And we do this in order because obviously we're not going to know 5 until we get down here. So that's why initially we're just doing the even numbers up here because these are the only numbers that we have the counts of initially. But once you get down here, you obviously have the 5's. All right, so let's actually start coding this. So original digits, we're going to pass in a string and we're going to pass back a string. So int count, int array equals new int 123. We saw this already. So for each character, we're going to convert the string to char array, and we're going to add each count in the count int array. Then we're going to define the nums, new int 10, which houses a 0 through 9. And basically we're going to do the same thing that I just showed sort of in the pseudocode. We're going to get the count of z's, the count of w's, u's, x's, and g's for each number. Then we're going to do the same thing with the odd numbers, getting, like I already explained, the count of o's, but you have to subtract out the o's associated with num 0, num 2, and num 4. And then finally, num 9 is the last number we're going to look at. All right, so then we're going to create a new string builder. And then we're going to loop through the nine numbers, basically, the 10 numbers. And then while the number is greater than 0, meaning there's the value in there, we're going to append that to the string builder. And because this is a post decrement, it's going to come back and assign each value actually to -1 so that we don't recount that. And that is pretty much it. Return this, I always forget this, return the string builder to string. So even though it's a number, it's going to be returned as a string. And that is pretty much it. So let's go through the debugger here and see if we can't make some sense of this. So I use the first example. So what we're looking for here is 0, 1, and 2. All right, so we got a new int array, count 1, 2, 3. So this is basically going to go through and add all the numbers, all the letters to the count int array. And you can see here W is actually 119. It's adding 119, and O is 111. Let's see, if you were to subtract 97 from this, which is the A, then you would get, the place of O in the first 26 letters of, 26 letters of the alphabet. But this is just behind the scenes, so I don't really care about that. Anyway, so we're going to get all the letters in this string here. All right, so now we're going to define a new int array of num. So now we're going to get the count of z's. And you can see, and if you look here in num, it put a 1 in the 0 spot. So we have 1, 0. 1 z, which corresponds to 1, 0. Same thing with the w. We have 0, 1, 2. So we have 1, 2. Now we don't have any of these. Now we get down here. Num 0, which is 1, minus num 2, which is 1, minus num 4, which we have none. So here we have a 0 left over, or I'm sorry, an O left over for the 1. And that is it. We don't have any other of these letters. So one thing to note is we only care about certain letters. So if you look here, like there's an E in here, in this string. We never check for the E because it corresponds to the 0, and so we're only looking for specific letters. All right, so we define this new string builder. We're going to loop through it. So if you look at nums, we've got number ones in the first 3 spots. So we're going to append that and go back, and you see now the num is -1 in the 0 spot. So we're going to append the 1. You see SB is 0, 1, and append the 2. So SB is 0, 1, and 2. And we're just going to go through the rest of the numbers. There aren't any. And return 0, 1, 2. And that is your answer. All right, well, hopefully that explains it in an understandable manner. So time complexity here is just O of n, the length of the input string. As it gets bigger, we're going to take more time to parse through it. And the space complexity is O of 1. We have 2 arrays, the count array and the num array. And actually, I forgot to run it through LeetCode, so let's do that quick. There we go, it is accepted, and let's submit it. See what we get. 54, let's try again. 99%, less than 42% memory. Okay, well, thank you so much for watching. Hopefully this makes sense, and we'll see you next time.